Welcome. This video is a follow-up to a video in which we found the line tangent to this circle here at this point using technology. Now I'm going to show you how to do this using implicit differentiation. So first, let's find the first derivative. So that is, we want to find the derivative with respect to x of both of these sides of this equation. So this is d over dx x squared plus d over dx y squared equals 0, since the derivative of a constant is just 0. Now this one's very straightforward. F of x equals x squared, so f prime of x equals 2x. Now, this one requires a little more thought. So let me write a little note here. We are treating y as a function of x. In essence, what you're doing is applying the chain rule. Let y equal some function of x, and we don't know what it is. Then y squared is equal to g of x squared. So now we just need to apply the chain rule here. That is, d over dx of y squared is equal to this derivative here. That is the derivative of a composition of functions. So this is the derivative of the outer function, which is 2, times the function itself. Since, again, if we were taking the derivative of x squared, you'd move the exponent to the front and keep your x. In this case, our x is just g of x. And then we need to multiply by the derivative of g of x. Well, in both of these cases, we have already defined y equals g of x, so we can rewrite this as 2y times dy over dx. And that goes here. So now we're not quite done with step 1 here because we haven't found dy dx. That's here. So now you're going to solve this as if this were some equation from algebra. So 2y dy over dx is equal to negative 2x. So dy over dx is equal to negative 2x over 2y, or just negative x over y. Wonderful. Now that that is done, let's find the slope of this curve at the given point. That is at 3, 4. dy dx evaluated at x equals 3 and y equals 4 is equal to negative 3 over 4, which is negative 0.75, and we had already seen that in a previous video. Finally, this last step is all algebra, and that's find the equation of the line. I like to use the point-slope form of a linear equation, that is y minus y naught is equal to m times x minus x naught. And I'll do that just right below here. So that is y minus the y naught value, so the y value of the point we're given is 4, equals our slope, which is negative 3/4 times x minus 3. This works out as negative 3/4 x plus 9 over 4 plus 4. 4 is simply 16 over 4, and 16 plus 9 is 25. So we end up with y equals negative 3x divided by 4 plus 25 over 4. So we end up with y equals negative 3x over 4 plus 25 over 4, which again is what we saw using technology. And again, to refresh your memory, here is what we got using GeoGebra, and here's what we got using implicit differentiation. Both equations are, equivalent. One's just in form of fractions. The other one is in the form of decimals. I hope you found this video helpful.